Hi, welcome to this video presentation by the Unknown India YouTube channel. This is the fifth and concluding part of the video series 10 Misconceptions about Indian Civilization. In this video, we are going to destroy the claims of the West that all basic and essential technologies that India has used or is using came from there. We will establish that many of these technologies were in use in India, that is Bharat, long before the time periods of Western claims of invention. Bricks have been an important component of construction in residential places, public structures, as well as utilities for a very long time. We are also told that the fire brick was invented in 1821 of Common Era by the Quaker potter William Weston Young, who lived from 1776 to 1847 of Common Era, partly in Bristol, England and partly in Glamorganshire, Wales. Of course, we also know that the much improved kiln design was invented by Frederick Hoffmann of Germany in 1858. But excavations done by Archaeological Survey of India in 4 Harappan sites, namely Kalibangan in Rajasthan, Rakhigarhi in Haryana, Dholavira and Lothal in Gujarat, have revealed that burnt bricks or fire bricks were used by the Harappans in a variety of construction applications as early as 4,500 to 5,000 years ago. A very detailed video called 5,000 Years Old Bricks was published by us some time ago, and its link is given in the description to this video. Please check it out. Several research papers on the earliest iron smelting in the world, including the one in the Journal of Archaeological Research, assert that the technology started in Anatolia, which is now part of modern Turkey, in early 2nd millennium BCE and later spread to Far East in the late 2nd and early 1st millennium BCE. But based on investigations in sites at iron smelting Malhar, located in the iron-rich mineral zone of Mid-Ganga Valley in the heartland of India, near Varanasi, there is evidence in the form of remains of ancient furnace and production samples that iron smelting started here in 1900 to 2000 BCE. A series of dating results on finds from various parts in India have also shown evidence of iron ore technology before 1800 BCE. A number of iron objects were also found in a place called Mailadumparai in Tamil Nadu, and the dating is 2172 BCE. In other words, iron smelting and use were very prevalent in several parts of India some 3900 to 4200 years ago, long before Anatolia, the Middle East or Europe started smelting and using iron. A very detailed video, First Use of Iron in India, was published by us some time ago. Its link is given in the description to this video. Please check it out. Zinc is an interesting and useful metal as it is used to make mock silver utensils and artifacts and also mock gold coins. It is also an alloying element for brass, which is popular for making vessels and also for bell metal and gunmetal. Because of its rust-proofing quality, zinc's modern uses include galvanizing iron and steel, ingredient in paints and chemicals, electroplating, hydraulic and marine valves, pipes and fittings, electric batteries, etc. It also has medicinal and nutritional applications. Zinc has a boiling point of 906 degrees centigrade, therefore, it would be in gaseous form at the temperature required to reduce its oxide ore to metal, which is 950 to 1100 degrees centigrade. In an open fire furnace, unless the vapors are trapped by means of condensation equipment, converting the vapors in the course of cooling into metallic zinc, they will combine with carbon dioxide in the furnace and form zinc oxide. Therefore, it is impossible to smelt zinc in an open fire furnace like iron, copper, etc. Zinc can only be produced by vapor distillation process invented in Zawar or Jawar 40 kilometers from Udaipur in Rajasthan. It is the world's oldest mining and metallurgy site, marking ancient India's acumen in the metallurgy sector. It is a prosperous mining region known for its magnificent silver jewelry. Zinc and lead mined from the Aravalli rocks, extracted through this unique distillation process, was shipped to Europe to bolster brass instrumentation for the Industrial Revolution. The earliest radiocarbon datings for the Zawar mines are 430 plus or minus 100 years BCE, that is 530 to 330 BCE. Old workings at Rajpura and Dariba around 375 BCE and Rampura Agucha around 370 BCE confirm the mining of lead zinc ores in the southern Rajasthan region from the 5th to 4th centuries BCE onwards. Zinc was produced on a commercial scale in Zawar since the 9th century CE. The Alchemy works Rasa Ratnakara of 13th century CE by Maharishi Nagarjuna and Rasaratna Samuchaya of the 14th century CE both contain passages detailing the process and equipment for producing zinc. The 2000 years old smelting technique of Zawar, which was lost to the world, was rediscovered by an Englishman called Dr. John Lane in 1726 CE after a visit to Zawar. He produced zinc by this Indian process at Swansea in southwest Wales, according to British scholars like Beckman and Professor Poster. The British metallurgist William Champion patented a process in 1738 of Common Era to distill zinc metal from calamine using charcoal in a smelter. This process remained in use for more than 100 years. What Champion patented was essentially the same process of high temperature distillation and condensation that had been in use in Zawar since the 1st century AD. This was sheer plagiarism. Many scholars attribute invention of zinc smelting to China. This is utterly nonsensical, as the Chinese started producing zinc only in the 18th century of Common Era, and they even called zinc only by the Indian name of Tutanag. Historians believe that a large number of Chinese monks who visited India to study Buddhism took back with them the knowledge of medicine, astronomy, zinc and brass technology, and alchemy. Recognition of Indian invention of zinc smelting came rather late. In 1988 of Common Era, the American Society of Metals, or ASM International, recognized Zawar mine as an international historical landmark. The ASM plaque reads, "At this site are preserved the zinc retort distillation furnaces and remnants of related operations. The village artifacts together with the temple ruins attest to the success of this metallurgical technology. This operation first supplied the brass for fine instrument making in Europe, a forerunner of the Industrial Revolution. Retorts are inverted clay pots used for distillation of zinc and are unique to Zawar, said to have been invented by the Bhil tribals, who were the original inhabitants of the region. Retorts were coated on the inside with condiments such as turmeric. Retorts were cylindrical with one end open and were about 30 centimeters long and 1 centimeter thick, with an internal diameter of 10 centimeters. Invention of the electric cell is wrongly attributed to the Italian physicist Alessandro Volta towards the end of 18th century of Common Era. But several centuries before that itself, the Indians knew how to generate electricity. Similarly, the discovery of oxygen and hydrogen in late 18th century is wrongly attributed to Cavendish and Priestley. Indian rishis knew about oxygen and hydrogen and that water can be split into the two gases several centuries before that. This is proved by this verse in Agastya Samhita by Maharishi Agastya, which is variously dated from 4000 to 2000 BCE. This verse means place a well-cleaned copper plate in an earthenware vessel. Cover it first by copper sulfate and then by moist sawdust. After that, put a mercury amalgamated zinc sheet on top of the sawdust to avoid polarization. The contact will produce an energy known by the twin name of Mitra Varuna, that is electricity. Water will be split by this current into pranavayu or oxygen and udhanavayu or hydrogen. A chain of 100 jars is said to give a very effective force. And to cap it all, electroplating is said to be discovered by the Italian chemist Brugnatelli again in late 18th century. Agastya Samhita also contains verses which detail electroplating procedure. All this was revealed to participants in an international conference of the American Chemical Society at Detroit in Michigan in USA in September 1927 by an American chemist of Indian origin, Dr. Varam R. Kokotnur. It was also published in the Minnesota University newspaper. Thus, we have demonstrated in this video through a few important examples that Indian technology was always far advanced and Indians had made inventions and discoveries several centuries before credit was given to Western scientists and engineers for these. There are many more such instances. We hope that some of us will be inspired by this video to find out more about ancient Indian technologies and also to take up these cases in international science and technology fora like Dr. Kokotnur did and obtain due recognition for Indian inventors and discoverers. Please check out our playlist of all videos on India's technology initiatives, as also our other videos in the full playlist, and also subscribe to our channel by clicking the respective links. Thank you.